Hello there. The paper I'm going to tell you about today is sitting there published for more than 2 years, but during that time I found a better way to convey its points and I want to share it with you. The paper itself is devoted to the location of gamma ray emission zone in the parsec-scale structure of a famous blazar 3C273. The first thing that we have noticed after we got the images of the source at 43 GHz were two distinct broad features that move downstream the jet, and each of them consists of different number of Gaussian components, but they are all well separated from adjacent parts of the jet. We have calculated centroid position for both of these clusters and used it to perform a kinematics analysis. And what we have found, I'll jump into figure 3. Both clusters move as a single component would move, but here you can notice that they have a simultaneous dip in their motion laws. It is not well visible on this plot, but when we subtract a linear trend from the data, we can immediately see that both clusters accelerate and decelerate simultaneously. Actually, they cannot talk to each other. They're tens of parsecs away from each other. So the only way to make this possible, to make coordinated movement possible, is to move the reference point, which is the parent core in this analysis. Another thing to note is that when the core moves downstream, its flux density rises. It could be naturally explained if there is a single blob of plasma carrying large values of particle density that comes from ejection process from somewhere near the black hole and propagating downstream the jet, and then it comes to the region where the parent core is. It brings higher particle densities, so it not only increases flux density of this region, but also increases opacity. And the parent core has to move downstream to let the particle density drop a little bit due to expansion of this blob to become transparent again. So two processes are happening simultaneously. The parent core moves downstream and its flux density rises, and vice versa. When the parent core goes backwards, upstream, its flux density decreases. That's the first point. Now to the main point of the paper. The first thing that we have analyzed was the connection between light curves taken in gamma rays and the light curves of the parent core and two stationary features that we have found in the jet structure at 7 millimeters. We have found that there is a correspondence between a brightest gamma ray flare and subsequent flares in the parent core and two stationary features. And this picture can be nicely and naturally explained by a single blob of plasma propagating from the black hole downstream the jet. First, in a region which is opaque to radio emission, it gives birth to a gamma ray flare, and then while propagating downstream and reaching optically thin portions of the radio jet, this blob of plasma produces flares in radio waves, first in the parent core and then in subsequent stand-in components, which is nicely visible from this figure. So we know, we have calculated the delay between gamma ray and radio light curves, and we know how far away upstream the gamma ray production zone is from the parent radio core at 7 millimeters. But this is not yet an answer to our question. We need to know exactly how far is it from the black hole. And here comes two additional things to analyze. First is so-called frequency-dependent core shift analysis. Since we had a multi-frequency data set at in radio waveband, we have performed a frequency-dependent core shift analysis to get an idea how far the apparent core at 70 millimeters is from the black hole. And it turned to be like 2 to 5 parsecs. It is a large range of distances, but it could be naturally explained when we consider the movement of the apparent core at 7 millimeters. So it can go closer to the black hole or further away. Bringing together all three types of analysis, the correlation between light curves, core shift analysis, and taking into account this apparent core movement, we can finally conclude that the gamma ray production zone is located 2 to 7 parsecs upstream from the 7 millimeter core, and it should be somewhere close to the black hole. And the most probable source of seed photons for the inverse Kopplung process is most probably the broad light region around the black hole. So the 2 points to take away are: first, that the apparent core of a quasar could move, and we have detected this for 3C273. And also we have located the gamma ray emission zone in the jet of 3C273. It is located close to the black hole, somewhere inside the broad light region. That's all for today. Check the details down there, and see you next time.